Example 4 wants us to find the indefinite integral of this rational function. So like we did in the previous video, I'm going to take my integrand, x plus 15 over 3x minus 4 times x plus 1. And my goal is to split this up into two fractions, one having a denominator of 3x minus 4, and the other one having a denominator of x plus 1. And I don't know what these numerators are for these fractions, so I'm going to call them capital A and capital B. And like we talked about in the previous video, I'm going to use the method of clearing fractions by multiplying by the least common multiple of all of the denominators, which in this case is 3x minus 4 times x plus 1. So if I go ahead and I multiply that through every fraction in my equation, my new resulting equation will be x plus 15 is equal to a times x plus 1 plus b times 3x minus 4. And I'm going to go ahead and distribute and then rearrange my terms. So give me a second to do that. Okay, so I went ahead and I distributed in these capital letters inside of my parentheses. Then I went ahead and I rearranged the terms and notice that I factored out the x as well. So again, we're going to use the method of comparing coefficients. So if it helps you, you can put a 1 in front of the x because that's its coefficient. And I want to compare the coefficient of the linear term on the left-hand side to the coefficient of the linear term on the right-hand side. And then similarly, I want to compare the constant term on the right-hand side to the constant term on the left-hand side. So let's go ahead and build our system of equations. My first equation is going to be a plus 3b is equal to 1. And then my second equation will be a minus 4b is equal to 15. This one is really nice and lends itself to elimination method because my a's are already lined up. So if I subtract these two equations, a minus a is 0. 3b minus negative 4b, be careful, that would be positive. So that's going to give me 7b. And then 1 minus 15 is negative 14. And 0 plus 7b is just 7b. So from here, I'm going to divide both sides by 7, and that's going to give me b is equal to negative 2. From here, I want to take that and maybe plug it into my top equation, and then that's going to give me a plus 3 times negative 2 is equal to 1. That gives me a minus 6 is equal to 1, and so finally we get a is equal to 7. So I'm going to clean up this a bit and then we'll return. So from our earlier work, we found that a was 7 and b was negative 2. So I'm going to go ahead and erase these, and a was 7, and then b is negative 2, so I could change this to a minus sign and then make b 2 like that. That's going to be the same thing. And so now if I wanted to integrate both sides of this, and now I can take that and break that up into two separate integrals, and I can also factor out the numerators. So earlier my students kind of fell into this little trap here. Be careful. In fact, let me kind of say students thought that the answer was 7 times the natural log of the absolute value of 3x minus 4 minus 2 times the natural log of the absolute value of x plus 1 plus c. Take a moment. Can you figure out why this answer is incorrect? Here's the reasoning. So this first integral here, if we use u substitution on it, or actually let me exclude the constant. So this integral right here, we want to use u substitution on it. So I'm going to come off and do that on the side. I'm going to let u equal 3x minus 4. And then du is going to equal 3 dx. And then if I divide both sides by 3, I get 1/3 du is equal to dx. So that integral can be rewritten as the integral of 1 over u times du over 3. And then we can factor out the 1/3 and just write du like that. And then that's going to equal 1/3 times the natural log of u plus c, and u, I'm going to go ahead and sub in 3x minus 4. And so really there needs to be a 3 in the denominator of my coefficient there. So let's go back. I'm just going to erase that and then change that to 7/3. And here is our final answer. So let's look at this example and do an alternative approach. This is the same integral that we saw in the previous example. And in the previous example, we used the method of comparing coefficients. Here, we're going to use a slightly different method. I think that this method makes things a little bit easier. However, the downfall of this method is that it doesn't always work, but the method of comparing coefficients does always work. So let's see how it works. Okay, so I just went ahead and I copied this equation from the previous example. And now what we're going to do is, because this is an equation, the two sides should be equal to each other regardless of what values we plug in for x. So what we're going to do is we're going to be strategic and plug in special values of x. Can you guess which ones we're going to plug in? If you said -1, you would be correct. So let's plug in -1 into both sides of our equation and see what happens. So I'm simplifying the a part. -1 plus 1 is 0, and a times 0 is 0. So that's why this is helpful, because what's essentially happening is we're eliminating one of the capital letters. And then next to the b, we have -3 minus 4, so that's -7b. And then if I divide both sides by -7, we end up getting that b is equal to -2. And if you remember from earlier, that's the same value we got for b earlier. Now what I want to do is I'm going to plug in another special x value. I'm going to let x equal, and now this time I want to find the value that's going to make this linear factor become 0, and that x value is 4/3. So if I plug this in on the left side, I get 4/3 plus 15 is equal to a times 4/3 plus 1. And then the b, that's going to be multiplied by 0, so that's essentially just going to disappear. So I'll just stop here. And you might be saying, oh no, we have to deal with fractions, but I'm going to use the method of clearing fractions again, and I'm going to multiply everything by 3. So that's going to give me 4 plus 45 equals a, and then I'm going to go ahead and also distribute in 3 into my parentheses, and that's going to give me 4 plus 3 like that. And then if we simplify, we get 49 equals 7a, and if I divide both sides by 7, I get a equals 7. And notice these are the same numerators that we got in the previous example. So I think this is a little bit quicker, a little bit easier, but you know, it's personal preference, so you decide what works best for you. In this next example, we want to find an indefinite integral. This one differs from previous ones because now in my denominator, I don't have two unique linear factors. So here, there are not two different or two unique linear factors in the denominator. This cannot be expressed in the form 5x minus 2 over x plus 3 squared, which is in the next item. We have x plus 3 times x plus 3. Notice that that's not equal to a over x plus 3 plus b over x plus 3 because those have the same denominator. So I could just combine them into a single fraction and we get capital A plus capital B over x plus 3, but there's no way that I could add two constant values together and get an x value. So that highlights why these are not equal. Also, you can see that they're not equal since there's just a single x plus 3 on this side, but there's two x plus 3s on the left side. So we can't quite go about this the same way if we have a repeat linear factor in the denominator. So however, it can be expressed in the form a over x plus 3 plus b over x plus 3 squared. So that's how we deal with it if we are dealing with repeat linear factors. And then we're going to do the same way. So we're going to deal with this equation by multiplying both sides by the least common multiple of all of our denominators, which in this case is x plus 3 squared. If we do that, my resulting equation will be 5x minus 2 is equal to a times x plus 3 plus capital B. And I'm going to go ahead and plug in a special value of x and be strategic. I'm going to let x equal -3. That should eliminate the a variable. So we have 5 times -3 minus 2 is equal to a times -3 plus 3. That's going to become 0, and then we have plus b. So that goes to 0, and we get b is equal to 5 times -3 is -15, minus 2 is -17. So now I'm going to come back up here and change b to -17. And then if I distribute the a, I get 5x minus 2 is equal to ax plus 3a minus 17. And notice here, I can just rely on comparing the linear factors because my only linear term on the right side is ax, and then here I have 5x, and so that means that a has to equal 5. Okay, so from earlier we found that a was equal to 5 and b was equal to -17. So I've gone ahead and I've rewritten my original integral, and we're kind of at this stage now where we have two separated integrals. And so our first integral is going to be equal to 5 times the natural log of the absolute value of x plus 3. And then notice in our second integral, we have to do something a little bit different. I'm going to use u substitution and set u equal to x plus 3. That's going to imply that du will equal dx. So then this is going to become the integral of 1 over u squared du. And I'm just going to rewrite that as u to the -2 du. And that's going to equal -1 over u plus c. And then the u value that we have up above is x plus 3. And then I still need to multiply that by -17. So finally, let me bring this down. So I'm going to multiply the -17 and the minus sign, so that gives me plus 17 times 1 over x plus 3 plus c. And here is our final answer for this one.